Here's problem number 9 from the book, page 743. And the directions here say use the ratio test to determine whether the series is convergent or divergent. And as I looked at this problem, maybe the first thing that kind of popped out is it is alternating. But I don't think AST would be of help here. I'm not sure, but the direction said use the ratio test. So for the ratio test, we have to find this ratio. Find the ratio of a sub n plus 1 over a sub n. And after I have that ratio, then I need to do the limit as n approaches infinity. So for this, I'll say a sub n plus 1 over a sub n. We'll do the absolute value of that, which pretty much does what? It just takes out that negative. But I'm going to write negative 1 to the n plus 1 minus 1 times 3 to the n plus 1. I'll just put that negative 1 in the numerator where I can fit it. And that's 2 to the n plus 1 on the bottom times n plus 1 cubed on the bottom. And there's my a sub n plus 1. I am dividing by another fraction. I learned from my calculus students in previous semesters, well, let's just go ahead and multiply by the reciprocal because that's what it's going to be in the end anyway. So that's 2 to the n times n cubed. Now it's negative 1 to the n minus 1 times 3 to the n. So I just recopied all of this. This is the a sub n right here. Start getting things that look similar together. So I'm looking at my negative 1s. In fact, those absolute value signs are going to do what with the negative 1s? Look, well, this would be negative 1 to the n. Last time I did not write this as a single fraction. This time I'm going to write it as a single fraction. So it's multiplication straight across. Use the commutative property to reshuffle what's in the numerator and what's in the denominator. So I have like 3 to the n plus 1 over 3 to the n. And then I'll have times 2 to the n, and that's 2 to the n plus 1 in the bottom. And then I have n cubed in the top and n plus 1 cubed in the bottom. So get things that look similar together, and you're looking at it then as 4 fractions multiplied together. And reduce these expressions. Well, the absolute value is going to do what with the negative 1? Totally get rid of it. Although if you simplified these exponents, you would end up with a negative 1, but we don't need to worry about that. Absolute value takes care of that. How about 3 to the n plus 1 over 3 to the n? That's 3. And what you're looking at right here is we're using this rule from way back, a to the m over a to the n. Let me rewrite that. A to the m over a to the n from algebra. That's a to the m minus n. So if I have 3 to the n plus 1 over 3 to the n, that's 3 to the n plus 1 minus n. The n's reduced, it's 3 to the first power. So from this part, I'm going to get 3. I'll just leave 3 in the top. What about the 2's? 2 to what power, and where's it going to be? 2 to the 1 in the bottom. And then I'll have n cubed and n plus 1 cubed. Now, I want to rewrite this again. I want to say, okay, so this is the absolute value of 3/2 times n cubed over n plus 1 cubed. That's the ratio. Now do the limit as n approaches infinity. So the limit as n approaches infinity of a sub n plus 1 over a sub n is the limit as n approaches infinity of the absolute value of 3/2 times n cubed over n plus 1 cubed. What is the limit as n approaches infinity of n cubed times n over n plus 1 cubed? That is 1. If you look at the degrees, the degree of the top is 3, the degree of the bottom is 3. It is leading coefficient over leading coefficient. I'm pretending I multiplied that bottom part out completely. N plus 1 times n plus 1 times n plus 1. And my leading term would be 1n to the third. This limit's 1. So the limit as n approaches infinity is 3/2 times 1, and that's 3/2. So there's my ratio, and according to the ratio test, if that limit equals a number and it's greater than 1, or if it equals infinity, then what do we know about the series? Diverges. So by the ratio test, the series diverges because this is greater than 1. Yeah.
Are we going to ever get an a sub n with addition or subtraction in the fraction for the sum?
I can't think of one, but that's not to say you'll never see it.
Okay.
Yeah.